Hi everyone, welcome to this video series on classical machine learning algorithms using Python. This video is primarily on overview of examples of machine learning, types of machine learning, and typical tasks that we can achieve using the machine learning models and some of the popular machine learning models. So let's get started. The topics that we will cover are going to be introduction. I'll provide some examples of machine learning and how machine learning is actually used in different scenarios. What is data meant for machine learning? What is model? We typically use the term model. What that model means intuitively. We'll try and understand that and types of machine learning and typical tasks that we achieve through machine learning models and some of the popular platforms. Some of the prerequisites, the knowledge of Python as a language, NumPy, Pandas, and some familiarity with SciPy, Matplot, and Seaborn would be really helpful. Statistics essential for data science is mandatory and must have gone through typical data pre-processing steps that we use in data science. So what's the definition of machine learning? Is actually a part of AI which enables the computers to learn and understand the patterns from the data. Now, what is the meaning of learn and pattern? That I'm going to explain in the subsequent slide with examples. What is the meaning of learning and patterns? So we will look at many examples here to understand the intuition behind patterns and learning. And then we use the learning after the model is prepared. We use the learning acquired by the model for predictions or making some kind of a decision. And also machine learning models, they are actually designed to improve the performance over time. And that's the significant difference between a typical programming that we do, which is very standard. Once we define the rules, we pretty much get the same result. That's not the case with machine learning. With incremental data and frequent training or frequent updates of the model actually performs better. We'll try and dissect each of these points with examples in the subsequent slide. So let's look at the first example, customer segmentation. Here we're going to talk about some customers that the company has, and we will try to understand machine learning from this example. So let's say the scenario is a retail business wants to understand its customer base, meaning what sort of customer segments that the company is dealing with, like premium customer, regular customer, and something like that. So the scenario is to identify distinct segments of the customer based on the purchasing behavior or some other profiling characteristics of the customer. So we apply the machine learning models to kind of have separation of the data. So let's say these points are your customers, and this is your one customer segment, and this would be another customer segment, and this is another customer segment. With the red dot here means this is like a typical customer in terms of a purchasing amount and the income. So this is how we use machine learning models to understand the segments, like based on the attributes or the characteristics of the customer, like a purchasing amount and the income. So how does this actually help? Is in terms of decision making. Tomorrow, let's say we have a new customer coming in. Let's say is here. So we can say this customer belongs to this segment, which is a yellow, and let's call this yellow as segment Y. So we can make a decision based on the existing customers. So this is what it meant by the model learns from the data, and using this learning, we make decision. Similar examples I'm going to show you in the next few slides. Let's say fraud detection. How do you make a particular transaction like a fraud alert? So financial institution aims to detect a fraudulent transaction. This is also called anomaly detection in the language of machine learning. So how do we do so? Let's say we have some data here, and this data is based on the transaction amount. Now, this transaction amount has typical pattern for both these transaction amounts here. Now, based on the pattern, some of the data points could be outliers, or could be extraordinary, or abnormal, and that's what is called anomalies. So this is another example of machine learning models learning from the existing data and making decisions on the future data. Let's look at one more example here, demand forecasting. So in the plot that you see here, the data is our existing data is the blue one. Now we apply a machine learning model on the data, existing data, and we learn. That means the model is learning the pattern. Now the pattern can be the average buying or average sales, or some complicated parameters as well. Now after the learning, we can make the predictions. We can say that the next few weeks or next couple of weeks, we see this kind of sales in the coming 2 weeks or coming 1 week. So that is another example of demand forecasting using the existing data. Let's look at one more example here. Let's say you have a couple of users, and the users are similar, and how they are similar based on their behavior or the pattern or some of the characteristics that the users have. Now, let's say this particular user has bought these items, and this user is similar. That means this user is similar to the user A. So let's call this user A and user B. So I can say that user A will also like this item, which is not yet purchased or viewed or recommended or rated by the user A. So this is another example of recommendation. Again, we use existing data, and the model learns the pattern from the data and is able to make decisions in terms of recommendation. Similarly, we have another example of sentiment classification or sentiment analysis, popularly known as sentiment analysis, where a given text is provided to the model, and the model is supposed to make a prediction whether the text is positive or negative in terms of emotion of the opinion maker. Let's say from the Amazon, someone has written, some review on the Amazon or some other e-commerce platform, and the platform wants to make a decision whether the opinion or the feedback given by the user is positive or negative. This is another example of machine learning. Topic classification is another example where from the existing topic, let's say we have a 100-page PDF or 100-page document, and we would like to find out the typical topics present in the article or in the PDF. And likewise, we have to detect if the email is spam mail or normal mail. That's another example of machine learning, algorithms being used to detect spamminess in the email. Some examples of sentiment analysis, positive reviews. Let's say this is the text, I love my new smartphone, and obviously the sentiment is positive. So how the model detects it is based on the prior data. So we need to provide lots of prior data to the machine learning model in order for the model to classify this new text as positive. Quite essential for e-commerce platforms, like, where the need is to do product reviews. Similarly, social media posts, again, similar objective. Someone has written some comment and you would like to classify if the comment is positive or negative. And likewise, the movie reviews, again, we have textual, you know, opinion on the movies, and we would like to classify if the movie review is positive or negative. Now, some of the advanced application of machine learning would be like summarization, where you summarize a large piece of document, let's say, 10-page document, into a smaller one. The objective is not randomly make it smaller, but to carry the meaning into the uh, abstracted, or the concise or summarized version. Machine translation is again a very modern application of machine learning, where we translate from one language to another. Let's say the input language is hello, how are you, and then you would like to convert it to some other language. Quite sophisticated implementation of deep learning algorithms are actually used here. Named entity recognition, again, a very popular and very advanced application, where the objective is to detect, let's say, in the piece of text, some names, or names of places, or names of organization, or names of buildings, for example, or cities, or phrases, or date and time, and that's called named entity recognition. This is again a very complex and sophisticated implementation of deep learning algorithms. Question answering system, these are also very popular applications of modern day machine learning algorithms using text data, where you're asking questions and the model is going to return an answer. And all of us are very familiar nowadays with the ChatGPT and the various large language models. We ask questions and the model actually returns the answer. So some example is, let's say the given text, Mount Everest is, highest mountain. Let's say this is a given passage or text, and the question is, who were the first people who reached there? So the objective of the question answering system would be to detect the names or named entities here from the passage and come up with a proper answer. Text generation is another popular application. Again, this is a very modern application based on a very sophisticated sequence-based model called RNN, LSTM, or GPTs, and BERT, and transformers. So let's take an example. Let's say the prompt is once upon a time in a faraway land, right? And after that, the model is going to generate the meaningful text after this. So this is another very good example of text generation. Data augmentation is a very powerful application of machine learning, and why it is useful is to compensate for lack of data. And most of the time, we have data shortage in our machine learning projects. And in order to compensate for shortage of data, using the existing data, we can manipulate, or we can augment, we can come up with variations of data, of the existing data, so that we have a diversity of the data and we can build our machine learning models. Now, one more modern day application is the information retrieval. Again, a very powerful one based on search engines. And again, we use sophisticated machine learning algorithms again based on the query. The model is going to return to you the relevant information from the various sources. It could be enterprise sources, could be internet sources, it could be some university library, it could be any of the repositories. Some other popular NLP application, NLP is natural language processing, which is based on text data, is keyword extraction, very similar to named entity recognition that I talked about. But key phrase extraction is more broad, let's say machine learning algorithm. So these three words would be like a key phrase, and you would like to detect those. Relations extraction is another powerful application of machine learning. Let me give you an example of relation extraction. Let's say the text contains some medical information and the patient is given some medication, um, and that medication name is, let's say, Med1, and the dosage is, one time in a day for 4 weeks, something like that. So this is relation extraction. That means that we need to link the medication name with the dosage along with the frequency and the duration. And that's called relation extraction. Very, very useful application in the medical domain. Similarly, the parts of speech tagging is a very powerful application again to designate certain words in the text as noun or preposition or adverb or adjective. And based on that, we carry out many of the downstream um, natural language processing based objectives. So essentially, what ML needs is data. So we need to provide the data to the machine learning model to produce a model. Okay, so if this is my machine learning algorithm, we have to provide certain names I have mentioned. We are going to go through most of the classical machine learning models, neighbors algorithm, naive Bayes, decision tree, neural nets, and the list is actually very, very huge, almost like 500 plus different algorithms that exist, maybe more. So the machine learning models need data. So we need to provide the data, and using the data, the model is going to learn what is going to learn. That learning is called the model. So the machine learning algorithm actually learns in terms of a model. So let's understand both the parts, what is data and what is model. So what does the data actually look like? Let's talk about a sample data set. For example, let's say the objective is to predict the temperature on a given day. Then what factors or what attributes define the temperature on a particular day? That could be, let's say, the average temperature in the last 7 days. Or it could be the temperature one day before or 2 days before, or the current month and current day and the week, and probably the year. Yeah, year may not be that important. And temperature forecast given by different agencies, and these are weather forecasting agencies. And let's say the temperature forecast by your expert friend could be another attribute, maybe. Now, these attributes define a temperature. Let's say, we have come up with this kind of formulation. Then the sample data set will constitute of these values here. So some of these values are called independent variables. and the variable that you predict, which is the temperature here, is called dependent variable. So that's an example of a data. Let's look at another example here. Let's say this is loan application. Again, let's say the objective is to predict the loan amount the applicant is eligible for. And again, we will have independent variables, means the variables which define or which are useful in determining the loan amount that can be sanctioned to that applicant. That's another example here. Automobiles data. Let's say the objective is to predict the kilometers per liter the car will actually run for. And again, the variables or the attributes which define or which possibly determine the kilometer per liter could be the number of cylinders the car has, the displacement again. So again, we are going to use the independent variables and the dependent variables. One more example here, and that's going to be, let's say the patient is diabetic or not, and the people who are diabetic or non-diabetic, they have some characteristics in terms of glucose level, blood pressure, skin thickness, insulin level, BMIs, and so on and so forth. Again, we make use of independent variable to determine the dependent variables. So dependent variables are predictions. Likewise, most of the machine learning algorithms are crafted using the data in a tabular form. So what does the model actually look like? So we saw the data, and the data has been given to the machine learning model, and now the model has learned from the data. So what it has learned is called the patterns. Now what that pattern actually means, let's try to understand the intuition behind the model. So again, I'm taking an example of customer segment. Let's say this is our dummy data. And we know the customers have segments A, B, C, and they have certain patterns of income and spend. We would like the machine learning algorithm to take the data, and my data is in this form. So, and I've colored it based on the classes A, B, C. And the job of the machine learning model is to find the separation between the classes. So the line, the hypothetical line that I have drawn, let's say the model is able to differentiate these two customer classes A and B. Let's say A is red and green is B, and the customers are separated by this line, and similarly here also the customers are separated by this line. Now this line that the model has determined is called learning or machine learning. The machine has learned from the data. Now, various machine learning models learn in a different way, which is what we're going to see in each of the machine learning models. The working of the machine learning model, how they work, and how they learn. Essentially, they will learn to differentiate the groups of data. That's essential for machine learning. So these lines that you see here is called the learning by the model, and this is also called pattern. Now, from where we are deriving the pattern? We are deriving the pattern from the data, essentially the columns called income and spend that is associated with class, means the category of the customer A, B, C. So this is called the model. Now, whenever we use the term model, that means the model machine learning algorithm has the understanding of the data and is able to differentiate the data in terms of groups or classes. Let's look at another example here. Now, this example is about the sales of a company based on the advertising money that the company is putting. And let's say this is a linear pattern. More advertising money, more sales. Well, in practical life, it may not be the case, but just for our understanding. So the machine learning model is going to learn. So this red line that you see here is the model has learned the pattern from the data, which is sales amount and the advertising money. And based on that, it has drawn a line, red line. This is called prediction line. That means if the customer is going to spend, I have a point marked green here, and let's say the customer is spending this much, then we can anticipate the sales volume to be around this green mark here. So that means we can make some kind of a prediction that for a particular advertising money or plan, we can anticipate that much of sales here. Let's define machine learning process in terms of how it evolved and the typical process flow that we use. And we will be using some simple example to demonstrate the machine learning flow. So let's understand the difference between the traditional programming that we talk about and also the machine learning programming. Where is the difference? The traditional programming is typically rule-based, and that means we provide explicit instructions for the computer in terms of program. And the outcome from the traditional programming is deterministic. That means whatever the rules you have defined, the output is more or less going to be very, very deterministic, not probabilistic. So that means the traditional programming is also limited in terms of adaptation. That means the changing data, the traditional programming is not going to change its behavior. Whereas in machine learning, we want the model to contextualize its understanding based on the data. That means the traditional programming is designed to solve a specific problem. Whereas the machine learning programming, it is based on learning from the data. That means if the data patterns change, then the machine learning models also must exhibit a slight change in the model behavior in terms of predictions or in terms of plots, in terms of decision making. Most of the machine learning models are actually probabilistic. That means not deterministic. It will provide you the best information based on the input that we provide. Adaptation and learning are the key characteristics of machine learning models. That means with increasing data or changing data, incrementally updating the model, the machine learning models start to give better result, well suited for online training or continuous training. So let's understand how things actually evolve for machine learning. So initially 1940s and 50s, Alan Turing introduced the concept of machine learning, or he defined the term called artificial intelligence. 1950s and 60s, we had initial ideas about neural net. Can you believe it? That's a long time back, almost like 70 years ago. We had some idea about neural nets, and it's called perceptron. 1960s and 70s, now the rule-based machine learning models came into existence. Um, a little bit of back propagation, which is a key characteristics of deep learning, was introduced. It was not used, but rather it was introduced. Now, the momentum changed or gathered velocity around 1980s and 90s with a lot of new machine learning models. For example, support vector machines. 1990s and 2000 with more and more computation power and also the availability of databases, data sets, ability to process lots of data. So there was time. So this was a time when the revolution, really sort of IT revolution happened in terms of storage and computational power. Early 2000 laid the foundation for reinforcement learning successes. The algorithm of reinforcement learning were introduced again much earlier, but successes were seen in early 2000. 2010s, lot of success in processing images, processing speech and audio, processing text. For example, language translation or machine translation, those were the major successes in 2010. Now we are talking about generative models, large language model, ChatGPT, Bloom, Hugging Face model, BERT, and transformers. So let's look at the process of machine learning. Typically, it has an input and then the algorithm which sits in the middle, which is a machine learning algorithm, and there is an output. The output is essentially the model. So you provide the input. The input can be, variety of sources. It could be enterprise data, mainframe, text, images, audios, and the format can be structured or unstructured. But remember, we have to convert unstructured data into a structured tabular format for the machine learning models to process. The output is the model's learning, which we discussed a couple of slides ago. So stages of machine learning starts with a data collection process, then we have a data preparation. These two phases are covered in the data pre-processing video that I prepared early in the series. And then we decide which model to use, which machine learning model to use. And this is where we will be focusing in the subsequent videos in this playlist. We will look at the characteristics of the machine learning model, how they are architected, how they work, on what basis we choose a particular model, and then we go through the process of evaluation and subsequently tuning or optimizing the model. In a typical data science project, the phase of data exploration, data understanding, data formatting, data illustrating, or the data massaging, whatever we call it, that takes up quite a bit of time. Almost like 50 to 60% of time goes into data management. Remaining 20 to 30% time is for machine learning. Typically, this is more like empirical data, not necessarily a rule. And after that, we have evaluation and deployment time. That means the success of machine learning is totally dependent on how good we process or how good we format our data, or what kind of data we provide as input to the machine learning model. Let's take an illustrative example and walk through the process of machine learning building. So step one, we define the objective. Let's say the objective is to forecast the temperature for a given day. for a location or a city. Now, in order to do this, we have to find out what are we trying to predict, and that means what are the target features. The target features is the temperature. In order to predict the temperature, what's the input data that we need? What kind of problems are we facing with the data? Is it the problem of binary classification, or is a problem of clustering or anomalies, or could be regression? So those decisions we have to make at this step. Step number two is data gathering. So we gather the data, all the necessary data that we think are instrumental in defining a temperature for a given day. We gather those data and go through the process of understanding and elaboration. Step three is preparing the data. Now we have to prepare the data. So we have gone through whole list of data preparation activities that are typically done. For example, missing value, duplicates, redundant values, or noise in the data, could be scaling, could be encoding, all kinds of data pre-processing. Now, data pre-processing does not mean a set of activities or predefined set of activities. Different type of data will require us, and also based on the objective, the steps of data elaboration can change. So step number four is data exploration. This is where we're trying to understand the groupings, try to understand relations, try to understand in terms of statistics like hypothesis testing, whether this column influences the other column or not, whether these values are outlier or extreme values, should we drop them, should we consider, and so on and so forth. Then comes the step number five is building the machine learning models. Now there are various categories and types of machine learning models: logical model, concept model, conceptual learning, geometric model, and probabilistic model. We'll go through each one of them, and in the subsequent videos, we'll look at each of the types of machine learning model. Now, how do we pick? That's another step in between. So there are considerations that we consider first to pick a model or pick a range of models for the problem that we are trying to solve. Step number six is evaluation. So now evaluation means how good is the model behaving with the data that we have, and also with the test data. Optimization phase is the most important phase where we're trying to optimize the model parameter for better predictions. And then lastly, we make use of the model for predictions. These are typical steps that we follow in machine learning projects. Now, what are the types of machine learning typically that we face? So I'm going to go through at a high level understanding of supervised, unsupervised, and so on and so forth. Typically, we have supervised, unsupervised, and reinforcement learning. These are major types of machine learning. Let me go through these types with the example as well. So let's look at supervised example here. So it's a type of machine learning which is trained based on some labels. That means we have to label the data. So what do we mean by labeling the data? So meaning the input data is paired with some corresponding desired output. Let's say given input data of temperatures and rainfall or wind pressure, humidity level, we can say this is a moderate day or it's a very hot day. So this is how we have to manually label the data. That means each of the row has to be tagged with desired label. And the goal of the supervised learning is to map the input to the label. See, the output is nothing but the label. So this creates the mapping between the input and the output is called the model learning. So let's take an example of labeling. For example, you want to classify the emails as spam or not spam. So these are sample emails and you can label based on the content. You can say this is spam, not spam, spam, not spam, and you could have thousands of such email text which you think are good for machine learning model to be trained. Let's look at another example. Let's say this is classifying iris flower. Let's say these are the classes of the flowers, Setosa, versicolor, and virginica. And the corresponding rows are these. And then you think if the sepal length is 5.1, 3.5, 1.4, 0.2, and that is Setosa. This is called labeling. Let's look at one more example. Let's say this is your apartment or houses in your area with the square feet, number of bedrooms, and so on and so forth. And this is the price. This is also called labeling. One more example, let's say the digits picture, and the picture could be handwritten digits, let's say 7, 6, 9, 2, and each of the picture has to be converted to a structured format. So that means this 7 that you see here is related to one row in the table. So for example, here this is 28 by 28 picture. So you would have how many columns? 28 multiplied by 28 columns here, and then the label is going to be 7. This is a labeling process which is mandatory before we do supervised models. Similarly, text data, some more text data here, examples, and then you could classify them. This text is technology related, this is nature related. So these are classes, and then in future, you have some text, then the model can predict the given text is technology or nature or, any other category. So essentially, supervised learning is the goal is to learn the mapping of input and the output, which is a label. That's called supervised learning. Some examples again here. Let's say the weather, temperature, and the number of visitors. Now that could be determining the number of visitors here. So the output here is the number of visitors here. Now, given a particular day with some input, you can predict how many visitors you can expect. That's the purpose of supervised learning. Now, supervised learning mathematically is also mentioned as something like x and y, where x is the input, so this is your input, and y is the output that you are predicting. Typically, we write like this: y is equal to function of all the input variables like x1, x2, and xn. So mathematically, this is how we represent a machine learning in terms of input and output. So where do we use supervised learning? Supervised learning is actually very popular because it has a lot of business use cases. One of them is image classification, speech recognition can be one application area, sentiment analysis, we spoke about it, can be another application area. Recommendation systems would be another application area. where you're recommending a particular item to some target user based on the similarity of the users, fraud detection, and many, many more such applications. The type of supervised, now there are two types of supervised learning. So one type is called classification. That means we have to predict a class. So that means my input data will have a label. So this is my input x1, x2, x3. And what we are predicting is a label which could be 0, 1, 2 or ABC or like Setosa, versicolor, virginica, right? Those kind of applications are called classification problem. Now, the other problem is again based on input data x1, x2, x3, and the y can be sales amount or profit or defect percentages or ratios or whatever. So that's called regression problem. Some of the examples of classification like spam detection. We spoke about it. Churn prediction. Is it the customer going to churn or leave the organization or leave our services? Yes or no. So that's called churn prediction. And sentiment analysis is again an example of classification. Dog breed detection, what breed this is. This is again an example of a classification. Disease diagnosis, whether this particular disease exists or not. Yes or no. So that's again a classification problem. Regression problem example would be house price, numerical value we're trying to predict here. And then temperature forecasting would be another example of regression problem. Stock market or stock price prediction can be another example. Fuel efficiency again deals with numerical values. So that would be a regression problem. Health parameter prediction, another example of regression. So let's talk about now the machine learning process flow. Uh, Very simple. First, we need to label the data. That means the input data has to be mapped to some output or target. Then we train the machine learning model. And after that, we use the model for prediction. Based on the prediction quality, we go through a process of evaluation and optimization. Now, next, we want to look at some example of unsupervised learning where we do not have any labels. So what is unsupervised learning? Imagine you have a big box of colored marbles and you don't know anything about these marbles, like, what distinct colors are there. So you would like to categorize them based on some criteria. Here the criteria could be color. So unsupervised learning is a method which we use to group the similar things together. So for example, here we would be, categorizing the red balls or yellow balls or blue balls together. So where do we actually use unsupervised learning? Quite a few areas. For example, you would like to group the patients with similar medical characteristics or genetic profile, or could be some symptoms of disease. Based on all these characteristics, we might want to group the patients here. And it's going to help the doctor in further diagnosis or providing medications or instructions and other things that we have in the medical domain. Anomaly detection is another useful example of unsupervised learning. Let's say a normal, and the machine knows about the normal MRI or X-rays, and then you're presented with unfortunately a patient's MRI which has some problem, then we can use the unsupervised model to say that this is an anomaly. So unsupervised models are typically grouping the similar data into groups of, or rather we call them cluster in the language of machine learning. So unsupervised learning, raw data provided to the algorithm, and the algorithm is now going to group the similar data into clusters. And that's what the objective of unsupervised learning. This is pretty hard in terms of implementation. Is easy to understand, but when it comes to machine learning, implementation of unsupervised model is very difficult. The reason is we do not have a way to measure how well the model actually group. There are some methods that we will see in our subsequent videos on unsupervised model, how we can use certain metrics to evaluate the performance of the unsupervised algorithm. Now, for human eye, it's very easy to say how many distinct groups or patterns exist, but that's not so easy for the machine learning models. As you try different machine learning models, you can see the variations in the output, and some of the model are really not good. For example, here, this is like one cluster, two clusters here, two clusters. This is like another one. Again, this algorithm divides this continuous data into again two different clusters. So different models have different strengths, and we have to evaluate and see which model actually works for our data. So we covered the supervised model and unsupervised. Let's try to understand the reinforcement learning, which is again a very popular, type of machine learning. Quite different than supervised models and unsupervised model. The purpose of reinforcement learning is also very different. Here we are trying to teach the computer to learn by trial and error. That's a completely different proposition here. In our previous case, we were providing the historical data in thousands and millions. Now here we are um, training the computer to learn by trial and error. So it's like training a pet or playing a game. The computer tries to execute different actions. I have put it in different color because these are the jargons used in reinforcement learning: actions, feedback, and learn. We're not going to go too deep into all of this, but just the basic idea here. In the subsequent slide, I have some examples which will make these things quite easy to understand. Essentially, the objective is to make the model choose the action in such a way that it accumulates most of the rewards. That means it achieves the goal. Let's take an example. So agent is called the computer in reinforcement learning, or the main software in reinforcement learning algorithm is called agent. And the example is game playing. So in the game playing, the agent learns how to play the game like chess, Go, or poker. Robotics, again, the agent learns how to make the movement of the robots in an optimal manner. Autonomous vehicles like self-driving cars, and there are many more other examples of reinforcement learning. Let's see some examples here. Let's say sales. Let's say you are a manager, you're managing a team of sales representative, and you have a team of sales personnel. So the goal is to maximize the sales revenue. Now, how do we, or how the salesperson can maximize the sales revenue? Now, RL, or reinforcement learning, can be thought of a way to train your team members to make the best decisions in different situations. That means a salesperson is dealing with multiple customers, and each customer dynamics is different. Situation is different, the demand is different, the pricing is different, and so on and so forth. So what mechanism actually would work is the salesperson's job to learn by trial and error, and then the goal is to reach the target or maximize the sales revenue. So the team members are agents. Environment is the market where the team members are operating. Each team member is taking an action. Maybe the action could be selling, not selling, or holding on, or providing some discount, or no discount, or product bundling. There's so many different actions that the sales team member can think of. Those actions are predefined. These actions are not random, not ad hoc, these are predefined. Now, after taking the action, this team member or a salesperson is going to accrue the reward. Now, sometimes it could be a positive reward. That means the customer is appreciating the proposals that this team member has made, or the customer rejected it. So, in both cases, you would have a positive reward or negative reward. The objective of reinforcement learning or the salesperson is to get as many positive rewards as possible by making a suitable action, judicious action for all the customers at the right point of time. Let's take an example here. Let's say the game. So you have two games here. On the left hand side, the AI does not know anything about the game. The right hand side, you have the AI trained and it knows how to play the game. The game is about catching the prey here. So let's see. Oh, okay, let me click here. So on the left hand side, you see here is just randomly moving around the green box, and is not able to catch the prey. But after a lot of trial and actions, here the AI is trained and it knows what action to take depending on the location or position of the object. Let's look at one more example here. Let's say this is the grid world where the objective is to allow the robot, the blue one is a robot, should learn how to reach the green spot without hitting the red blocks. So that means the AI has been trained and the blue robot knows at each of the step or each of the cell what action to take. That means it knows by taking this action in this particular state is going to maximize the reward or is going to reach the goal. So this is the grid world. The robot can move one unit to the right, left, up and down. And that's the grid that you have. The agent cannot see anything. The way we design the grid reinforcement learning problem, we don't tell the agent about where the blocks are. Agent only knows the neighborhood, immediate neighborhood, just like left, right, and and if the agent hits the safe path, which is a white one, it will get a positive reward. If it hits the red one, it's going to get the negative reward. So it's going to try millions of times and then it's going to learn in this particular cell, if I take left, that's more rewarding. And that's the basic idea here of reinforcement learning. So the goal is the robot is blue and the states are, each of the states here marked in orange or red and the white. And the possible actions are up, down, left, right. and the reward is -1 if the robot tries to enter the orange cells, and 0 for any other path or any other cell. So the training process is the iterative one, and that's going to last for hours and hours and hours. Sometimes the complicated reinforcement learning problem run for months in terms of training. So after the training, at any point, the agent knows what action to take in that particular point. And then it goes to the next one and next one and next one, and the objective is to reach the goal which has the maximum reward. This is quite different than supervised learning and unsupervised learning that we talked about. Similar example of a game playing using a chess, and this is how we actually train the algorithm to play the game of chess. Again, a lot of experiments are done, a lot of humans are involved in training the agent here. And the agent, by trial and error and playing with real humans during the training time, it learns the optimal behavior, and then it is ready for the ready for demo or ready for real predictions. So one more example here, the Pac-Man. So this is again an example of reinforcement learning, how Pac-Man is eating the or capturing those white balls, because it knows where to move or what action to take at a particular time in this grid. All right, so that's defines our typical machine learning types like supervised, unsupervised, and reinforcement learning. So now let's understand reinforcement learning in terms of definition. I put the definition in the end after the example so that we can easily relate to some of the things like how to map situations to actions. This is by random trial and error. And the goal is to maximize the reward overall. The agent, the learner, is not told what action to take. So we are not directing it. Instead, we are saying, if you go left and you hit something which you're not supposed to, then you're going to get the negative reward. Otherwise, you're going to get the positive reward. This is called reward engineering. Sutton and Bato, the famous writers of this book on reinforcement learning. Okay, so let's summarize typical tasks that machine learning algorithms actually do. We have discussed quite a lot about what machine learning algorithms can do, how they do it. So now it's time to look at or summarize some of the typical tasks that the machine learning algorithms do. For example, is this A or B? That means we are saying, is this particular data belonging to a class A or B? Or is this data weird? That means it is anomaly or not. For example, the banking transaction is anomalous, something weird, out of normal pattern. How much or how many means what's the temperature outside, how much of sales I'm expecting in the coming quarter. That is called how much or how many. That's supervised. How is this organized means how many groups of data or what kind of grouping, what kind of clustering that we have. That's called unsupervised. What should we do next? This is reinforcement learning problem. So is this A or B? Some of the example, will this customer renew the subscription? Is this an image of a cat or a dog? Will this customer click at the top of the link or not? Will this tire fail in the next, few hundred miles or something? Does rupee 5 coupon or 25% result in more customers or something like that? Yes or no. So whenever we have this binary decisions like yes or no, That's called A and B type or two-class classification. Extension of that is called multi-class or A, B, C, D. Which animal is this image? It could be dog, could be cat, could be rat, can be hare or horse. What is the mood of the tweet? Positive, negative, extremely positive, extremely negative, or neutral again. So this is a multi-class, and so on and so forth. Is this bizarre, weird, or anomalous? Credit card transaction, is this does it look like fraud? Does it look like anomalous, out of normal pattern? Is this combination of purchases very different for this particular customer? Let's say I'm the customer. Typically, I purchase between 100 rupee to 10,000 rupee, and then suddenly I'm making a purchase of, let's say, more than that. So that's anomalous here. How much or how many is a regression problem. What's the temperature would be tomorrow? What's the sales in the next fourth quarter in my Kolkata unit or something, and how many new followers that I'm going to get. So whenever you deal with numerical predictions, that's called how much or how many. In other words, called regression problem. Few other application recommendation systems, natural language processing, where we use these supervised and unsupervised algorithm. Now, the key thing is to understand the classical machine learning that we talked about and some of the deep learning. I marked them in green, so wherever we have this green perceptrons, deep learning, recurrent neural nets, word embedding, BERT transformer, and language models, these are modern day that we talk about, although the origin is way back in 1950s. The blue ones are called classical machine learning, let's say the neighbors algorithm or decision trees or support vector machine. These are the algorithms that fall under classical machine learning. So popular ML platforms that we typically see. So some of these are I mentioned here. TensorFlow is quite popular for deep learning. Scikit-learn is for classical machine learning that we talked about a while ago. This is open source. TensorFlow is also open source. Weka used to be popular, like 10 years ago or 15 years ago. Now it's not used that much. But Scikit-learn is very popular. TensorFlow is extremely popular for deep learning. Popular cloud-based ML platforms, again, you might have heard about AWS, like Amazon SageMaker, Microsoft Azure, Hugging Face, or Google Vertex AI. These are very, very popular cloud-based machine learning platform. That means they allow you to build a complete end-to-end machine learning solution. Out of this, the ML flow is a open source, platform. That means it allows not only to build application, it also allows you to host it on some cloud for typically free, but not for all enterprise applications. Some of the programming languages that are popular, mostly Python is used for machine learning, deep learning, computer vision, reinforcement learning. Most of the machine learning we use Python as a language. R is mostly used for statistical purposes. I have mentioned Java, but again is not very common to see Java implementations using for machine learning. C++ is indeed used for machine learning, especially for very high-end machine learning like computer vision, robotics, reinforcement learning, which requires really a lot of computing, load. JavaScript, Julia, and Scala. Out of these, Scala is quite popular because of the distributed abilities, which allows you to process the data in across the clusters of machines. So some Python components for machine learning that we will use in our next videos. I just listed some of these here, the Python core. like language data structures and some of the plotting abilities using Python core, and then NumPy, SciPy for statistics and mathematics. Both NumPy and SciPy are used for numbers and mathematics, but SciPy is advanced mathematics. NumPy is for basic linear algebra and basic mathematics. SciPy is pretty advanced mathematics. Pandas is for data handling and plotting. So we will use quite a bit of pandas in our subsequent videos. Scikit-learn is for machine learning using the data. And this is what we are going to focus on. Plus, there will be hundreds of third-party libraries that we will need to use to build the machine learning models. We're going to focus on scikit-learn for most of the classical machine learning models. How do we use scikit-learn module? First, we need to understand the problem. Secondly, data exploration, data pre-processing, then choose the model. This is where the most of the emphasis in the playlist will be how to choose a particular model, what is the criteria. Then comes the model training, making predictions and evaluating the model, then optimizing. The essential part is how do we choose a model? What is the criteria to choose a model? This is where we're going to spend bulk of our discussion time in the next series of videos. So essentially, before we choose a model, we need to understand how the model actually works, intuitively at least, and sometimes a little bit of maths might be involved. How we use this algorithm within the Python code. Each of my Python code will show you how to use this within scikit-learn or the programming interface. What type of data the algorithm is actually suited for. So there are not all algorithms are suited for all kinds of supervised learning. So we'll have to discuss that. And how do we optimize or tune the model performance? That's pretty much it in this overview on machine learning. It was a long video, but I hope you found it useful. In the subsequent videos, we will talk about specific machine learning algorithm. Thank you all and happy learning. See you in the next videos.